In this video, we're going to cover the ratio test. So, let's say we have an infinite series, a sub k, with all positive terms, and then the limit as k approaches infinity of a sub k plus 1 divided by a sub k equals some number L, then A, the series converges if L is less than 1, B, it diverges if L is greater than 1, and finally, this test is, unfortunately, inconclusive if L equals 1. So, let's do an example. Say we have an infinite series from n equals 0 to infinity of 9 to the n over negative 2 n plus 1 times n. So we realize this is an alternating series. However, if we just take the absolute value of this series, we can easily avoid that condition and make it all positive terms. So, L equals the limit as n goes to infinity, the absolute value of n, or 9 to the n plus 1 divided by negative 2 to the n plus 2 times the quantity n plus 1. Now we would just divide this by the original. However, dividing by the original is the same as multiplying by the reciprocal. So just for time's sake, we're going to flip it, skip a step, over 9 to the n. So, let's simplify. So the limit as n goes to infinity of this, let's see, well the 9 and 9 have the same base, so we can just simply subtract n plus 1 minus n. We know this is simply 9, so there are those two. Now we have n and n plus 1. Oh no, excuse me, we have negative 2 to the n plus 1 minus negative 2 to the n plus 2. Again, same basis, so we can simply subtract the exponents. Remember, this is a quantity and to distribute. So we have negative 2. N's cancel. 1 plus negative 2 is negative 1. So we have 2 to the negative 1. So then this goes on bottom. And then we simply have the n and the n plus 1. So we're going to write the n up there, n plus 1 down there. So, the 9 over 2 is simply a constant, and although this is a negative, we are inside an absolute value. So I'm just going to pull this out front to simplify. And we're dropping the absolute value due to this all being positive. So the limit as n goes to infinity of infinity over infinity plus 1, well, just to simplify, let's use L'Hopital's. We get 1 over 1, which simply is 1, obviously. So 9/2 evidently is greater than 1. So what does this mean? Well, let's go back to our conditions. B states that the series diverges if L, in this case 9/2, is greater than 1. So in this case it is. Therefore, the original series, 9 to the n over the quantity negative 2 n plus 1 times n, diverges by the ratio test.